Hello. During our question sessions, which I have every day, and I encourage you to join, a lot of people have asked about this type of question. So let's take a look. How many cubes with side lengths of 1/2 centimeter does it take to fill the prism? So we're going to look at this two different ways. The first way is we'll find the volume of this large prism, volume LP large prism, and the volume of this small prism that is 1/2 by 1/2. So let me draw that down here. So this prism is 1/2 centimeter by 1/2 centimeter. By 1/2 centimeter. Okay. So how do you find volume? Volume of a prism, length times width times height. We'll call this the length, we'll call this the width, and we'll call this the height. But really, depending on how it's flipped, they could all change. The key is consistency. One thing I want to do is switch this to a mixed fraction. To do that, you multiply the denominator times the whole number, so 4, and then you add the denominator on top. So that's 5/2. Another way to think of it, 5/2, if you put that into your calculator, it'll give you 2.5. 5 divided by 2, 2.5, same as 2.5. Okay, so volume of large prism equals 5/2 centimeters times width of 2 centimeters. I'm going to call that 2 over 1 times height of 1 centimeter. And I'm going to call that 1 over 1. So, a couple ways we can think about that. We can just multiply the tops. 5 times 2, 10 times 1, 10. Look, these centimeters all have an invisible 1 here. So when you multiply variables, let's pretend that was an x, that you add. When you multiply variables, you add the exponents. Centimeters times centimeters, centimeters squared, times another centimeters, centimeters cubed. And then 2 times 1 is 2 times 1 is 2. Or, 10 divided by 2 is 5. Or we could have looked at this and said, oh, look, 5 times 2 divided by 2, boom, boom, that's a 1, that's a 1. 5 times 1 times 1, 5 centimeters. Either way you want to look at it. So if we had cubes that were 1 centimeter by 1 centimeter by 1 centimeter, then 5 of those cubes would fit in here. However, that's not our question. Our question is we have cubes of 1/2. So let's find the volume of SP, or small prism. The same length times width times height, same equation. A lot of people make the mistake of saying, oh, that's the volume is 1/2. No. When we actually take the time and we multiply this times 1/2 centimeters times 1/2 centimeters, we get 1 times 1 times 1 equals 1. 2 times 2 times 2 equals 8. 2 times 2 is 4 times 2 centimeters cubed. It's much smaller because in each dimension, in the length, width, and height dimension, It's half of the original. So imagine you could put 1, 2, 3, 4 in the front if they're all half. So there's 1 here, 1 here, 1 here, 1 here. There's 4 up front and 4 in the back, making 8 cubes, making each one of these cubes 1/8 the size of that original 1 centimeter cube. So these are 1/8 the size. Therefore, the question becomes, if you divide this into this, how many are you going to get? So think it as the volume of the large prism divided by the volume of the small prism, which, if we substitute in our numbers, 5 centimeters cubed divided by 1/8 centimeter, what do we get? So a few things I'm going to do. I'm going to put 5 over 1. What do we do with this sign? Dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to rewrite this. The reciprocal of 1/8, 8 over 1. And this centimeter, oh, interestingly, this centimeter comes down. That's what cancels these out. So 5 times 8 equals 40. And it's not 40 centimeters cubed, because the question is, how many of these little cubes? 40 little cubes fit inside large prism. Okay? Another way to think of that, just let that sit for a second. If we want to try and visualize this, we can think, how many of these half cubes fit on this side? So if it's 1 centimeter tall, a half would be down here, half centimeter cube would be up here. And if it's 2 centimeters wide, look, 4 across, 2 up. Now, how many? So same thing. It's 1 centimeter high, so it's split in half. But now there's 5 halves. How many halves go into 5 halves? Well, 5. 4, 5. And then we could extend that over there. Notice all these parallel lines. I'm making these lines parallel to those lines. It is parallel lines how I do this 3-dimensional. Notice the front are parallel to the back. This line down the middle, I attempted to make parallel to there. Obviously, this is harder. So what you'll find is that you'd fit, if this is 5 small boxes wide, 4 small prisms long, and 2 small prisms high. The other way you can think, number of small cubes would equal 5 times 4 times 2. 5 times 4, 20, times 2, 40. Oh, same answer we get here. So we can think of it as the volume of the large prism divided the volume of the small prism. Or we can think of cutting this up into the number of prisms that can fit into each dimension. 5 of these small prisms can fit in this length dimension, 4 in the width dimension, 2 in the height dimension, and then we multiply that. I hope that helps your understanding. Please join my sessions. I'll have one every day to ask questions, and then I'll try to make videos to show some of those questions that came up.